Okay, the third law, the power law, is actually easier to sort of show. Okay, we've only got here log to the base a of x. Okay, so we've got a single log here, but there's a k in front of it. Okay, k multiplied by this log, and the law says that this could be rewritten as log to the base a, so a single logarithm, but then that x then is the power k. Okay, so what you need to think of here is when you've got this, you could sort of take that k up so it becomes a power of x, okay, which is what's happened there, isn't it? Okay, you end up with that result there. Well, let me show you why it works, okay? Well, we'll start off with what we've got here, yeah, the logarithm, okay? So we've got, let's let log the base a of x equal to m. So remember, logarithm has got to equal something, okay? It's power, so we call it m again, right? And if I've got that, remember then what I can do, okay, I can get rid of the logarithm, right? I can swing that base over, and I'm left then with x equals a to the power m, okay? Now, what I'll do then is I'll look at the sort of result I've got here. I've got x to the power k, yeah, all right, in that logarithm. So let's look at what x to the power k actually is in terms of my definition here. So x to the power k, well, I've got x to equal this, so I'll substitute this in here, okay? So how I do that is, well, I appreciate this is x, okay, but then I need to put it to the power k, so perhaps I'll use a bracket. So this is my x, okay, and then it's to the power k. Now, with rules of indices, again, we apply, right? You just need to appreciate here, when you've got one power raised to another, quite simply, it is multiplying the terms, okay? That's what's going on there. So that will be the rules of indices there, just multiplying the terms. Then I can look at what I've got, right? I've got x to the power k equals a to the power mk. Now suppose I want to work out that power there. Well, I've got this base and I swing it over, and I've got log to the base a of xk equals to mk. All right. Last step then, well, I've defined my m, haven't I, to be log to the base a of x, so I substitute that in. So my m is log to the base a of x, and then I've got my k at the end. So you multiplying, these two things are multiplying, so I'm timesing it by k. So I've got that. This is my result effectively. Obviously I'm timesing that by that, so I'll put the k at the front to make it look better, and I get my result. Okay, and this result works both ways, often useful as we see now in the questions coming up in the next video.